Hello students, this is Indrani ma'am from Sir Prasayan. In this lecture, I am going to explain some questions on alkyl halides chapter. These are important questions for competitive exam. First question, which of the following is not expected to be intermediate of the following reaction? One reaction is given and four options are there. These and these are carbocation. You know carbocations are reaction intermediate, and this is oxonium ion. Now what is happening here? I is substituted by OH. So when a compound reacts with solvent, it is called sulfolysis reaction. This is one example of sulfolysis reaction. So what is happening here? Take the starting compound. You know this is good leaving group. So you break this bond. What will happen? We are getting here this carbocation and I minus. So removal of I minus is giving this carbocation. Now see, this carbocation is your option D. This carbocation is secondary carbocation because with this carbon two more carbons are attached. This is secondary carbocation. Now if you check valency of this carbon is having valency 4. So here this is bonded with 3 carbons. So obviously here one hydrogen is there. Now you shift this hydrogen with this bonding electron from here to here. So what will happen then? 1,2 hydride shift is taking place. We will get here carbocation and here this hydrogen is coming. So this is there in option number B. So that is also present here. Now what will happen? Water is there in the reaction medium. It will attack. Now see here this carbocation is tertiary in nature because this carbon is attached with 3 more carbon. So tertiary carbocation is more stable than this secondary carbocation. Now water will attack here. We will get this OH2 plus. This is present in option number C. So which one is not present then? Option A is not present. This is not possible. So this option A is your answer. Now next question. What is the major product obtained in the following reaction? This dibromo compound is there. On the arrow ammonia is given and here ethanol solvent. Now what is the product? So ammonia is there, it is nucleophile. So what will happen? Nucleophilic substitution will take place. What will happen here? Nucleophilic substitution takes place here. Now see, this is having lone pair. And at conjugation, here double bond is there. So if you break this bond, that lone pair will be involved in resonance. So if it will involve in resonance, then resonating structure will be this one. Here negative charge CH2Br, and here if it is shifting electron density in this direction, this is becoming positive, their lone pair will be donated. So this CBr bond is having partial double bond character. So it's not easy to break this bond for nucleophilic substitution. So where the nucleophilic substitution takes place? If this will break, then you know stable carbocation, benzylic carbocation you will get. This is benzylic carbocation. So here this nucleophile will attack and you will get CH2 NH3 plus Then by removal of H plus from here, will give this product. So option A is your answer. Now see next question. Here fluorine and bromine is there. We are treating it with 1 mole of sodium iodide in acetone solvent. We have to find out the major product here. 4 options are there. You know, alkyl iodides are prepared by the reaction of alkyl chloride or bromide with NaI in dry acetone. This is called Finkelstein reaction. This is example of nucleophilic substitution reaction. We know I minus, this is poor nucleophile, but it is strong leaving group because it is less basic and highly polarizable. Now what will happen if you treat it with Rx? We will get this Ri and NaX. We have seen iodide is poor nucleophile. Then how the reaction is taking place? This reaction is taking place because in this reaction alkyl chloride or bromide is treated with sodium iodide to form Ri and NaX. Now see, NaI is having higher covalent character. So in acetone is polar aprotic solvent. So in acetone, this is soluble. NaI is soluble. But after reaction, depending on X here, X may be chloride or bromide. So here you can get NaCl, NaBr after reaction. And this is more polar in nature, so it is not soluble in acetone. So it is forming precipitate. This is the reason that this reaction is going in the forward direction. Now we know between Br and F, Br is good leaving group because leaving group ability is decreasing in this direction. This is best leaving group, then bromide, then chloride, then fluoride. So Br and F both are present, so this is better leaving group than F. So what will happen? This will go, here I am showing, if you are using 1 mole, then obviously this will go, and from NaI, I minus will attack from opposite side. This is SN2. So inversion of configuration will take place, and since we are using 1 mole, so major product will be this one. Here inversion of configuration takes place, so option B is your answer. Next question. Which is the correct coordinate diagram for the following solvolysis reaction? So here one solvolysis reaction is given. 4 energy profile diagrams are there. First you have to find out the steps of this reaction. So what are the steps? Write this substrate. So break this bond, CBr bond. You will get this carbocation. This is tertiary carbocation. It is stable carbocation. Carbocation is planar, so this nucleophile water can attack from either from this side or from this side. So here you will get a mixture of 2 products. Here if CH3 is above the plane, OH will be below the plane, and if CH3 is below the plane, OH will be above the plane. So here you will get a mixture of these 2 products, OH2 plus OH2 plus. Here CH3 is above the plane and this is below the plane, and here CH3 is below the plane, OH2 is above the plane. Now what will happen? From here removal of H plus takes place, from here or here and here. So we will get here CH3 OH plus here OH and here CH3. So how many intermediates are there? This is one intermediate, this is carbocation intermediate, and here this is oxonium intermediate, oxonium intermediate. So two intermediates are there. So here how many intermediates? Transition state 1, transition state 2. Between two transition state there is one intermediate. Here three transition states are there, and between two transition state one intermediate. So here how many intermediates? Here 1 and 2. Two intermediates are there. Here only one intermediate, here also one intermediate. So two intermediates are there actually in this conversion. Therefore, option B is your answer. Two intermediates means three transition state. Hope it's clear to you. If you like, please subscribe. Thank you for watching.